We are in Unit 2, Lesson 12. We're taking what we've learned one step further and writing and graphing a system of linear equations. Everything we've done up to this point has been one linear equation. And we've learned the details of that one linear equation, what it means, how to represent real-life situations, how to find the vertical intercept or the y-intercept and the slope and what those values mean. Very important. Now we're doing a system. So now we have two equations and what the solutions mean, what they represent. So yeah, a system of linear equations means two or more, we're just doing two or more linear equations. Let's recall what it means to solve a system of linear equations and how to do it by graphing. All right, so Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound and walnuts cost $8 a pound. Diego spent $15 on both ingredients. So $4 a pound for raisins, $8 a pound for walnuts, and $15 total. Okay? Decide if each pair of values could be a combination of raisins and walnuts that Diego bought. All right, so 4 pounds of raisins and 2 pounds of walnuts. So 4 pounds of raisins times 4 and 2 pounds of walnuts times 8. How much would that be? So 4 pounds of walnuts is $16. So no, it's not. Because Diego spent $16 on raisins and $16 on walnuts, but only spent $15 on both ingredients total. Okay, so no. Now how about 1 pound of raisins and 1.5 pounds of walnuts? So we have $4 of raisins and $12 for walnuts. 4 plus 12 is 16. He only has $15, so no. All right, let's try 2.5 pounds of raisins. They're $4 a pound. That's $9 for raisins, and 0.75 pounds times $8 would be $6. Oops, I pushed the button on my pen again. $6 for walnuts. Well, 9 plus 6 is 15. So yes, it is a possible solution. Let's try this one. 3.5 pounds of raisins. That's $14. And 1 pound of walnuts. That is $8. So no, that's too much money. He only had 15 bucks. It's a good warm-up though, huh? So here's a situation you saw earlier. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound, and walnuts cost $8 a pound. Diego spent $15 on both ingredients. Write an equation to represent this constraint. Let X be the pounds of raisins and Y be the pounds of walnuts. So we do raisins are $4 a pound, plus walnuts are $8 a pound, and he spent $15. Using graphing technology to graph the equation. Use graphing technology to graph the equation. Okay, I'm going to pause for a minute and get my graph out. I was going to get my graphing calculator out, but I realized you guys won't be able to see it because of how I'm doing the recording, so I'm sorry. So we just wrote our equation, and I graphed it. All right, I can actually change how we look at it here. I want my x-axis. I only need the positive x's, right? Because that's all we're going to look at. And it looks like I just need it to go a little bit further. And x was the raisins. And then y-axis, again, from 0 to, it looks like, not far. And my label is going to be walnuts. Okay, I'm going to drag it just a little bit because I like to see just a little more detail. But yeah, I'm positive. So this is what works. Now, if you go to your curriculum, it says, complete the table with the amount of one ingredient Diego could have bought given the other. So if I have 0 raisins, I'm clicking on my graph, I need 3.75 pounds of walnuts to make the equation true. Again, I don't know where I'm looking when my head's down there. So to fill out the table, the first blank for 0 raisins, oh no. For 0 raisins, you need 1.875 pounds of walnuts. Okay, 1.875 is the same as 15/8 pounds of walnuts, right? I'm going to go back there. So 15/8 or 1.875 pounds of walnuts. If we have 0.25 pounds of raisins, I can plug everything into my equation there, or I can come over here. And I can look at my graph and say when raisins is 0.25, walnuts is 1.75, okay? $1.75. Okay, this can get kind of tedious. I don't really like using graphs. I would much rather use the equation. So for this next one, I'm going to substitute in my walnuts. So 4x, we don't know how many raisins, 8 times 1.375 equals 15. I'm going to solve that for x. So 15 minus 8 times 1.375 gives me 4, and if I divide both sides by 4, I get 1. I'm going to check that. Raisins 1, what does walnuts? Kind of hard. There we go. Oh, it's hard to get it. 1.375, okay? So I could use my graph. It is so tedious though. Okay, so we can fill in the rest of this either by using the graph or by using algebraic method. This is all algebra. All right, so complete the table with the amount of one ingredient Diego could have bought given the other. Be prepared to explain or show your reasoning. We did. Here's a new piece of information. Diego bought a total of 2 pounds of raisins and walnuts combined. So now we have one equation that talks about how much money Diego spent, 4x plus 8y equals 15. Now we also can say Diego bought so many pounds of one plus so many pounds of the other and bought 2 pounds total. Okay, 2 equations. It's a system. Pretty cool. Write an equation to represent this new constraint. Let x be the pounds of raisins and y be the pounds of walnuts. Use graphing technology to graph the equation. Now we have graphing technology. We're graphing a system of equations. We want them both to be on the same graph because this blue one shows us just the weight of the raisins and walnuts, and the red one talks about the money. And where they both intersect is the sweet spot. Okay, that is exactly the right amount of money and exactly the right weight of ingredients. 0.25 pounds of raisins and 1.75 pounds of walnuts are the only amount of each that are the correct solution. There's only one solution. Here, there are infinitely many solutions to the red equation all by itself. There are infinitely many solutions to the blue equation all by itself. But you do the system of equations together, there is only one solution, and it's this one. Okay? So now, if we wanted to fill out this table, we could go over to the graph and click on it. But here, I think we can do this on our own. So raisins and walnuts. If we have 0 raisins, we have 2 pounds of walnuts, because this is just an easy addition and subtraction. Everything's going to add to 2. All right, 2 minus 1.375 is, 2 minus 1.375, I multiplied, 0.625, 0.75, 0.25. I'm just making sure everything sums to 2. All right. That last one, if I bought 3 pounds of raisins, I can't, because it said that it has to be 2 pounds exactly. Yeah, that last one doesn't work. I can't buy 3 pounds of raisins because I only bought 2 pounds of raisins and walnuts combined. Okay, the answer here would be a -1, which is not possible. So Diego spent $15 and bought exactly 2 pounds of raisins and walnuts. How many pounds of each did he buy? Explain or show how you know. Well, graphically, we saw it. If we go over to the graph, it's 0.25 pounds of raisins and 1.75 pounds of walnuts, because that's where the 2 graphs intersect. So I can say 0.25, 1.75. Okay, graphically, it's where the 2 lines intersect. Algebraically, I can plug those values into both equations. I have 4 times 0.25 plus, is it 8? I think it is. Yep, 8. 8 times 1.75, and that should equal 15. And it does. And then I should be able to plug that into the other equation, which is just x plus y, and I should get 2. It's the only ordered pair that's going to make both of those equations true statements. So how many possible combinations of raisins and walnuts meet both constraints? Only 1. Because graphically, you only have 1 ordered pair that is both a solution to the blue line and the red line. And how do you write a system of equations? What is the solution to the system below? This is how you write a system of equations. You write your first equation with your squiggly line and your second equation. And the solution is 0.25, 1.75, because it's the only ordered pair that is both true, that is true for both the first equation and the second equation. All right, so here are some situations that relates 2 quantities involving 2 constraints. For each situation, find the pair of values that meet both constraints and explain or show your reasoning. A dining hall has a total of 25 tables, some long rectangular tables and some round tables. Long tables can seat 8 people and round tables can seat 6 people. So long tables can seat 8 people. I keep losing my tablet. And round tables can seat 6 people. On a busy evening, all 190 seats at the table are occupied. So how many long tables and how many round tables are there? All right, we're not sure. A dining hall has 25 tables. So I've got X long tables, we'll do that, and Y round tables. So X plus Y equals 25. We're not sure how many round and how many rectangular. But I do know that long tables seat 8 people and round tables seat 6 people. And 190 seats are occupied. So I have a system of equations. One of them deals just with the number of tables. and 1 deals just with the number of people. A system of equations. And really all I did was talk through each description and put equations to them. Sounds really easy, I know. All right, so let's try to see if we can solve for this. I'm going to go ahead and solve one of these equations for one of the variables. Let's subtract x from both sides, and I'm going to have 25 minus x. And then I'm going to substitute that in for the y value here. This is super duper important. Please follow along. So I have 8x plus 6 times, instead of y, I'm substituting. Okay, now I need to distribute the 6 through the parentheses. I have 8x plus 6 times 25 is 150 minus 6x equals 190. Collect like terms. I have 8x minus 6x, that is 2x, plus 150 equals 190. Subtract 150 from both sides. I'm left with 2x equals 40. Yep, and divide both sides by 2. X equals 20. So I have 20 long tables. If I have 20 long tables, how many round tables do I have? 20 long tables. I'm not sure how many round tables, but I have 25 tables total. That means that I have 5 round tables. So it's not impossible. It is kind of challenging, but I know you can do it. So system of equations, and I solved. Okay, another one. A family bought a total of 16 adult and child tickets to a magic show. Okay, so 16 adults and child. So the number of tickets total is going to be 16. Adult tickets are $10.50 each, and child tickets are $7.50 each. They spent a total of $141. So I already have an equation set up for the number of tickets, and I have an equation set up for the number or the amount of money. So adult tickets are A and child tickets are C. So I know A plus C equals 16, and then $10.50 A plus $7.50 C equals $141. So I have 2 equations and 2 unknowns. Let's do this one graphically, okay? So I have A plus C, which I'm going to do X plus Y equals 16. I'm just zooming out. I'm going to hit this wrench and say that X is no longer raisins, but it's adults. And this is children. Okay, the other equation we had was 1050 X plus 750 Y equals 141. Okay. So this shows me, if I hide this one, if I sold 0 kids tickets, I would be selling 16 adult tickets. If I sold 0 adult tickets, I'd sell 16 children's tickets. Okay, if I put the money constraint in there too, I need to sell exactly 9 children's tickets and exactly 7 adult tickets. It's the only solution that works for both equations. So 7 and 9. 7 plus 9 is 16. That works in the first one. Let's check the second one. 1050 times 7 plus 750 times 9. That should equal 141. Hold on. 141. I knew it would be right. Desmos does a pretty good job. All right, let's try this one. It's our last one. A poster shop. Han paid $16.80 for 2 large posters and 3 small posters for his favorite band. So our money equation would be equal to $16.80, 2 large posters, plus 3 small posters. Kieran paid $14.15 for 1 large poster and 4 small posters. So that would be 1 large poster, which we don't have to write the 1. 4 small posters equals $14.15. All right, let's try it. So 2x, x is large, plus 3y, y is small, equals $16.80. That's the first person, and then 1x, which we never have to write the 1. 4y equals $14.15. We have precisely, how can I buy 4.95 posters? Okay. Oh, it's money. Sorry. So it's $4.95 for X, which is the large poster, and $2.30 for the small poster, because it's the only ones that work. So large is $4.95, and small is $2.30. Okay, good job. All right, let's just summarize. What do you notice about the strategies used? I always have 2 equations. Usually one deals with just counting things and the other one deals with money. But yeah. All right, I think we are good. Yep. All right, so we can explain what we mean by the solution to a system of equations, and we can explain how the solution is represented graphically. I can also explain what we mean when we refer to 2 equations as a system of equations, and I can use tables and graphs to solve them. I prefer algebra. I can use graphs. Tables are okay, probably my least favorite. All right, I hope you enjoyed that.